If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where we are solving previous year IIT JEE questions. So today we will be solving 4 questions, question number 24, 25, 26 and then 27. Okay, then let's try to solve these questions. Now if you come to 24, the slope of the line that touch both the parabolas and this and this. So how to tackle this one? This type of questions I think we have solved in earlier also. You take one tangent, you perform here y equal to mx, m is here 1. It should touch means if you put it there, they should give only one solution. T should be only 1. So if you put it there, it is mx plus 1 by m, a is here 1. So if you put it there, discriminant, that discriminant should be equal to 0. So you know m is equal to half. Next you come to 25, the common tangents to the circle x square plus y square equal to 2. This is a circle, and the parabola y square equal to 8x. This is the common tangent, either this or this, you can see. Touch the circles at the point P and Q. So it touches the circles at P and Q and touches the parabola at R and S. Then the area of the quadrilateral PQRS. So it is a trapezium, you can see. This line and these lines are flat lines. By symmetry you can see these two will be parallel lines. So how to find this one again? So you find the slope tangents of this one. It should touch this one. So you can use this one, or what I have told you to do this one. You can try with this one, because this line has to be tangents with this one. So from the origin the distance should be equal to radius. Here the radius is root 2 and the origin is 0 0. So if you take the distance from 0 0, it will be 0 minus 0 plus 2 by m divided by under root 1 plus m square. That should be equal to root 2. That is your origin. So if you take square both sides, then if you solve it, then you will find final expression is this one. Or you can, this one also we have seen, this is the condition of tangency of circle, both are same line, so the ratio should be same. Either way you can go. So ultimately you will get m square cannot be minus 2, so m is equal to plus 1 or minus 1. So once you know plus 1 or minus 1, then you can know these lines. Okay, if you know this line, then you can find these points also. How? Because you know at what point this tangent touches. In case of parabola, it becomes very easy because it is tangent, so you know m is equal to 1 by t. Because in parametric form it is 1 by t. Okay. So and what is the point at which you are drawing the tangents? In parametric form it was 80 square 280. So because t is here 1 by m, so if you write it in m format, it will be a by m square 2a by m. So you know m is equal to, one line is this, one line is this. Two tangents I think. Both are 1 and minus 1. I think I have done, it will be minus x. One will be plus 1. Plus 1 is x plus 2, both plus. If you put minus, both minus. Okay, so if you put 1, then it is 2 comma 4. If you put minus 1, then it is 2 comma minus 4. This point you know. So RS, this is R, this is S. So you need to find PQ, because it was something of this trapezium form. So this point is 2 4, this point is 2 comma minus 4. And then for the circle, again for the circle what you can do, because this formula again I have not given, but for circle you know what is the condition of tangency at x1 y1. If it has to be tangent, then it has to satisfy that ss1 equal to 0. So ss1 equal to 0. So x1 y1 is equal to here 2. But your equation is y equal to x plus 2. So this should represent same line. So from here you can find x1. So x1 by 1 should be equal to, if you take y that side, because x and y are on the same side here, if you write it in this fashion, it is x minus y is equal to minus 2. Then x1 by 1, then y1 by minus 1 is equal to 2 by minus 2. So you can find your x1 is equal to minus 1, y1 is equal to plus 1. So one point will be minus 1 comma 1, and another point you have to compare this one again with another line. Another line is this one, that is x plus y is equal to minus 2. So if you compare again with this one, so this is one point, again x1 by 1 plus y1 by 1 is equal to 2 by minus 2. So again you find both are minus 1. So you know these 2 points also. So if you know all these points, so how to find the area of the parabola? So sum of the parallel sides into that length of the distance between the parallel sides. What is the distance? This point is minus 1 comma 1, minus 1 comma minus 1. This point is minus 1 comma 1. So obviously 0 0 is somewhere here. So here it is 2, here it is 1. So distance is 3. This is the height, distance between parallel points. And this length, this is 2, because it is 1, this is 1. So this is 2, this is 4 4 8. So 8 plus 2. This is 8, this is 2. So 8 plus 2, sum of the parallel side, distance between the parallel side. If you do this one, you will find it is 15. Now if you come to 26 and 27, both are linked question. A, R, S, T are the non-zero numbers where they are defining P, Q they have not given, R and S are the distinct points on the parabola, y square equal to 4ax. Suppose P, Q are the focal chord. So because P, Q is focal chord, now you know T1, T2 should be equal to -1, so you can write the coordinate of Q directly. And the lines QR and PK are parallel, where K is a point, K, 0. So you can think it of this way, if you want to draw it, a parabola of this fashion PQRS, so a point is K is a point 2a, 0. Suppose if I take y square equal to 4ax, so this is the parabola they have given, so it is a, 0, so 2a, 0 will be somewhere here, so this is your K. So what they have seen, PK is parallel to QR, so you should write it in such a way, PK, so that suppose if I take QR, so it should be PK, it is P, so this is Q, this is R. So you can see this one, PQR. So QR is parallel to PK. K is the point. Now because you know PQ is a focal chord they have given, so something, suppose this is focus, for just spare me, you think this one is focus. So because PQ is a focal chord, so T1, T2 -1, so T2 will be -1 by T, because here it is T, so you can write the coordinate of Q. It will be Q by T square minus 2a by T. So what is the slope of this QR? That should be the slope of PQ. So you can write the slope. Don't see that slope of a chord. Again, their direct formula it is written. So you can apply this one, or you can directly apply this minus this divided by this minus this. So if you do both way, this minus this divided by this, that will also give you. So here direct formula is given. How it is direct formula is given? So because it is 80 square 281. So again this formula I am explaining how to find the slope of a chord. And another point will be a2 square, because both will be the point of the parabola only, because they are chord. So if you find the distance between the slope, so what is the slope? These points. So y2 minus y1, 2a, t1 minus t2 divided by a, t1 square minus t2 square, so a plus b into a minus b, so it will get cancelled. So you can see it is 2 by t1 plus t2. That's why here t is 1 by t and here t is r. No need to remember this formula, you can directly apply this minus this minus, because this much thing you can do in the exam also. No need to give extra burden in your mind by remembering this one. So okay, so if you do this one, that should be equal to the slope of PK. So what is the slope of PK? So P you know, so 2at minus 0 divided by 80 square minus 2a. So if you do this one, you will find R is equal to this one, that is your option D, t square minus 1 by t. Once you know this one, then the next one, if st is equal to 1, then the tangents at the point P and the normal at the point S of the parabola meet the point whose ordinate is. So st is equal to 1 they have given, and the tangent at the point P. So this is the tangent at the point P and the normal at the point S. So S we have not marked till now to the parabola. So suppose this is S and you draw a normal. So this touches at the point this one. So you need to find the ordinate. So you know the slope of the tangents at P. So this is the slope of the tangent. So x by t 80, not t square. So this is the slope of the tangents at the point P, because P is t point. P is parametric form is t. You know this is the parametric, and S is parametric form is S. So what is the normal at S? This is the normal at S in terms of parametric form. That is S. We generally write it in terms of t, but here S point is given in parameter is S. Now they have given your ST is equal to 1. So S is equal to 1 by T. So you can put it there, because you need to find the point Y. So you need to solve these two and find Y. That's it. So if you put in place of S 1 by T, so it is this. So you can solve this equation and this equation, because this tangent and this parabola, this equation and this equation, if you solve, you find this one. If this is number 2, this is number 1, then you solve these two. You need to find Y only. So just if you add, your X will get cancelled. So if you add these two, so 2Y you will directly get, you will get Y is equal to this. So this is given in your option B. If you like the video, then press the like button and please give your valuable comments in the comment section.